right, this is part 2 of lesson 6-2, solving systems of equations using substitution. In the previous lesson, we went over how to do that. You have two equations. You use one of them as an equation, and you use the other as sort of a tool that you isolate one variable, get x or y by itself, and then substitute it into your other equation. So hopefully you guys remember that okay. If not, go check out that video. And now we're going to use some word problems. So I'm only going to solve 3 word problems in this video. The first 2 are very similar, and the third one we're going to solve the same way, but it's just slightly different. So we're going to call this using a table, because we're going to create a system of equations and then solve it using a table. All right, so example 1, how much of a 10% saline solution should be mixed with a 20% saline solution to obtain 1,000 milliliters of a 12% saline solution? What? Are we in chemistry now? Like, what are we doing? Okay, no, this is a math problem. And just think of it as like when you were a kid and you'd mix food coloring together, or maybe you even do that now, or you'd just water it down, you know, kind of thing. So think of it like colors if the saline part doesn't really get you. But a 10% saline solution means it's a lot of water and a little bit of salt, so it's kind of salty. A 20% saline solution means it's got more salt in it, so it's really salty. And we're trying to mix those two together to get something kind of in the middle, right? It's actually 12% here is closer to 10 than it is 20. So I'm probably going to be using a lot more of this than this. So our goal here is to figure out if the two of these together, if I pour some of this into a cup and then I pour some of this in with it, I end up with 1,000 milliliters total, and when they're mixed together, it becomes 12%. So how many of each one am I doing? It seems impossible, right? But it's not, I promise. Okay, so we've got this table. We're going to set it up. First thing is I want you to think about 2 things. I want you to think about the total number of milliliters. So the total amount of liquid. Doesn't even matter what the saline part is, what the percentage part is, just how you pour one in a cup, you pour the other in a cup, together they equal 1,000, right? So that's what we're first going to write up here. So I'm going to write amount. That's what's going to go in this line. And then in the bottom line here, we're going to actually put the percentage, so the percent saline. Okay, and then in these columns, I'm going to represent the 10% solution, the 20% solution, and then when I mix them together, I get that 12% solution. Okay, so the amount. How much of the 10% solution do I use? How much of the 20%? And then how much of the 12% do I end up with? All it tells me is that I end up with 1,000 milliliters of 12%. So I know this is 1,000. Do I know how much of each one I use? Nope. So I'm going to call this one X and this one Y. Or you could have done it the other way too. It doesn't really matter. Okay, so some of this plus some of this, add them together, you get all of this, right? We're going to write an equation out of that in a second. Okay, the percent saline. Okay, well, if this is how many milliliters of the 10% I use, now I have to account for the 10%. So I'm going to take the number of milliliters and multiply it by 10%. And when you write a percentage, when you're multiplying, you change it to a decimal. So 10% is 0.10. So the 10% saline solution times the number of milliliters I have of it is represented by 0.10x. Okay, so we're going to do the same thing here. The 20% solution times the number of milliliters I have of it. And then we're going to do the same thing here. The 12% solution times the number of milliliters I have of it. In this one, I know the number of milliliters. Okay, so we've got this table here. We showed just the total amount of liquid, and then we actually showed the percent of saline, right? So now what the heck do I do with that? So now I'm going to write an equation. So I know when I add these two together, they equal this. So I'm going to do that. X plus Y equals 1,000. X represents the number of milliliters of 10%. Y represents the number of milliliters of the 20%. That doesn't change. X and Y represent the same thing the whole time. Down here, they still represent the number of milliliters of the 10% solution. Now we're just multiplying it by 0.10. So if I ended up with, let's say, 10 milliliters, this is going to be 10 and this will be 10. That doesn't change. But what I'm doing with it changes. Okay? So now, since this plus this equals this, I'm going to do the same thing here. This plus this somehow adds up to this, right? So 0.10x plus 0.20y equals, and then 0.12 times 1,000 is, move it 3 points over, so 120. So this is my system of equations, and I came up with it for my table. So there was nothing up here in the problem that gave me a system of equations. I just had to think of two things. Number one, how much physical liquid do I have? And number two, what's the percent of saline in everything? So amount of physical liquid, percent of saline. I wrote my two equations with it. Okay, so now I can just go back to the algebra part of this, right? Solving system of equation, not the chemistry part or whatever. So in substitution, using substitution, number one of your equations is going to be your tool, and the other one's your equation. Well, this clearly looks like a messy equation. So this top one's going to be my tool. And to use it as a tool, you have to get one of the variables by itself. Doesn't matter which one, you can pick X or Y. Doesn't matter because you're going to end up plugging it back in and solving for the other variable anyways. So it doesn't matter which one you start with. All right, so I'm going to use this top one as my tool, but before I do, I'm going to change it so that I get X by itself. So all I'm going to do is subtract Y from both sides here. So I'm going to have X equals 1,000 minus Y. That's going to be my tool equation. And I'm going to use that in this equation. So wherever I see an X, I'm going to replace it with 1,000 minus Y because they're equal. X is the same thing as 1,000 minus Y. They're equal. So down here, I'm going to write 0.10x. Oh, sorry, my fault. 0.10. This is what I'm replacing. 0.10 times 1,000 minus Y plus, and then just keep repeating the rest of this, 0.20y equals 120. So all I did here was replace the X with what X is equal to. This is literally all I did. Same exact equation, I just replaced X with what X is equal to because it told me I could. Okay, so now I can solve. So I'm going to distribute. The only variable in this equation now is Y, so I'm going to solve for Y. So 0.10 times 1,000 is 100 minus 0.10 times Y is 0.10Y plus 0.20Y equals 120. Combine like terms, negative 0.10 plus 0.20 is positive 0.10. I'm trying to get Y alone, so I subtract 100 from both sides of my equal sign. 120 minus 100 is 20, and then I divide by 0.10. These go away, and Y equals, and when you divide by a decimal, your decimal's back here, so I'm going to add another 0 onto the end, right? Because this is 0.10. So this is actually going to be 200. If you're confused on that, just use your computer. So Y equals 200. So I solved for Y. Now I have to solve for X. So I can either use this equation or I can use it after I rearranged it. It doesn't really matter. I'm going to use it after I rearranged it. X equals 1,000 minus Y. X equals 1,000 minus Y, and it says right here Y is 200. So 1,000 minus 200 equals 800. Okay, so our solution here, remember our solution is always an ordered pair, X comma Y. My X is 800, my Y is 200. Don't switch those just because we solved for Y first. It's still the second number in the ordered pair. So 800 comma 200 is my solution. But in a problem like this, you don't only have to have the solution, you have to actually have your system that you solved as well. So where's my system? This is my system. These two equations, and then I solved them and I got this solution. So what does that mean with my word problem? How many of the 10% solution did I use? 800 milliliters. How many of the 20% did I use? 200 milliliters. So does it make sense that I used a lot more of this and just a little bit of this if I end up with a 12 per, yeah, it's a lot closer to 10 than it is to 20, right? It's 12. So I used a lot more of the 10% and just a little bit of the 20 to bring it up just a little bit, the saltiness up just a little. Okay, so hopefully that makes sense. We're going to do another problem exactly like it. Okay, example number 2. We only have 3 total. We're on number 2. How many gallons, a very, very similar problem. How many gallons of a 12% acidic solution and a 20% acidic solution are needed to obtain a 100-gallon 18% acidic solution? Now, I kind of paraphrased this from the original problem, so I didn't do a great job of writing that, but it's how many gallons each of a 12% and a 20%, right? So how much of this plus how much of this do I need to give me 100 gallons of an 18% solution, right? So I'm going to write my 12%, my 20%, and my 18%. And first, I'm going to think of it as just the number of gallons, right? Just the actual amount of liquid that I have. And then second, I want to think about the percent that's acidic. Okay, so how many gallons of the 12% do I have? Don't know. X. How many of the 20 do I have? Don't know. Y. How many of the 18 do I have? 100. Okay, percent acidic. Well, if I have X gallons and those gallons are 12%, I'm going to represent that with 0.12X. And I have Y gallons of the 20%, so that's 0.20Y. This represents how much acidity, how acidic the liquid is, right? And this represents how acidic this liquid is, okay? And then for this one, 0.18 times 100, okay? So I set it up the same way I did the last problem. So now I know that when I poured this into a cup and this, I guess not into a cup, a big vat or something, right? Something huge. When I pour these in together, then the total amount of liquid I have is 100 of the mixture. So I know X plus Y equals 100. And then I also know acidic wise, when this amount that I pour in has this much acidity, this amount I pour in has this much acidity, and when I mix them together, the mixture, which is 100 gallons, has this much acidity. So this plus this equals this. So 0.12X plus 0.2Y equals, and then 0.18 times 100 is just 18. Okay, so this is our system. And remember, in substitution, because we're using substitution, I need a tool and an equation. So this top one's going to be my tool. And I want to get either X or Y by itself. Doesn't matter which one. So I'm going to get X by itself. X equals 100 minus Y. Just subtract Y from both sides. Like a literal equation. Okay, so this is my tool now. And so in the other equation, wherever I see X, I'm going to replace it with this, right? So 0.12 times X, which is 100 minus Y. And then just finish the equation, plus 0.2Y equals 18. I say 0.2Y because 0.20 and 0.2 are the same thing. Okay, so now I can start solving, distribute 12 minus 0.12Y. Combine like terms, that's going to be 12 plus 0.08Y. Subtract 12 from both sides. And then divide by 0.08. Now you're at home, so you probably have your calculator in front of you. I do have a calculator. I do own one, but I don't try not to use it that much because I'm old school. So I don't have one here next to me, and I'm filming on my phone, so I can't use my phone. So how the heck am I going to divide this, right? And I don't want to get into decimals and weird stuff. So all I'm going to do is get rid of the decimal on the bottom by multiplying by, I need to move this over 2 spaces, and then it becomes 8. So what number has 2 zeros in it? 100. And whatever I do to the bottom, I got to do the same thing to the top. So that's 600 on top and 8 on the bottom. So now this seems doable. I can divide 600 by 8, right? 8 goes into 60 7 times. So x equals, oh, I'm not an x, I'm a y, sorry. Don't do that. Don't do that. We're solving y. I saw my little time sign and I put x, but it's y. We're solving for y. So y equals, 8 goes into 60 7 times, but 7 times 8 is 56, so we got 4 left over. So then I've got 40 here. 8 goes into 40 5 times. Just use your calculator if that's confusing. Okay, so y equals 75. So how many gallons of y do I use of the 20% mixture? 75 gallons. And if together these equal 100 and this is 75, what does this have to be? 25, right? But we can do that mathematically by coming up here, plugging in. You can use either equation, but why would we use this one with decimals when we can use the top one that's easy? Just plug in 75 for y and solve for x. I'm going to use this one. X equals 100 minus y. X equals 100 minus y, and y is 75. So x equals 25. Okay, so my solution to this system, I would write it as 25 comma 75. And that is referencing this whole situation I set up here, right? How many gallons of the 12% solution am I using? 25 gallons. How many of the 20, here, I'll put it here. How many of the 20% solution? 75. A lot more of 20, right? And between 12 and 20, 18 is a lot closer to 20 than it is to 12. So it looks like I'm going to use a lot more of this guy, right? If we were using food coloring and our mixture was really, 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 really red, and this was red food coloring and this was water, which one do you think we'd use more of if our mixture is really, really, really red? Probably a lot more of the food coloring. If it was really, really, really light pink, we'd probably use way more of the water. But, you know, in this case, 18 is closer to 20, so it makes sense that we use a lot more of the 20 than the 12. Okay, hopefully that's making sense for you. Last problem. This is a football one, so anybody who's sick of the chemistry stuff, here you go. All right, at the end of the 2007-2008 football season, 38 Super Bowl games had been played by the American Football Conference and the National Football Conference. The National Football Conference won 2 more games than the American Football Conference. How many games did each conference win? So, guys, I get it. Listen. If you're like getting a headache right now, like I don't know how to sort this out in my head. I get it. That's why we're doing it this way. So just start small. Okay, what are they talking about here? They're talking about 2 football conferences that played each other for 38 games, right? These 2 specific conferences played a total of 38 games. So who won, right? One of the 2 teams had to win. We're not counting ties, or we're not doing ties or anything like that. So either the AFC won the games or the NFC won the games, or they both, you know, some won some lost some. But total, there's 38 games, right? So I'm going to call the games that the AFC wins, I'm going to call those X. So AFC X and the NFC Y. Okay? So the number of games that they won plus the number of games that they won equals 38, because they only played 38 games, and these guys won some and these guys won some. So X plus Y equals 38. And in a system of equations, when you have a variable, in the entire system, in all the equations, the variable still represents the same thing. It never changes. X doesn't change from representing here the number of games the AFC won to then in the next equation we're going to write, it's not going to represent something different. It's still going to represent the number of games the AFC won, okay? The next thing it says in the problem, so now we know these 2 football conferences won 38 games total when they played each other. The NFC won 2 more games than the AFC, okay? So how many games did the AFC win? X, right? How many games did the NFC win? Y. So we're still going to use those. This Y is 2 more than X. The NFC won 2 more games than the AFC. So we're going to say X plus 2 equals Y. These are our two equations. In a system, you need two equations. So we thought, first of all, just like in the mixture problem, total number of gallons or total number of liquid, right? Total number of games. That's our first equation we're going to write. And then we use the second part. Now, normally it's been asking us about acidity or saline mixtures. In this case, it's just how many games a certain conference won. So the NFC won 2 more games than the AFC. If the AFC won X, add 2 to that, and that's how many the NFC won. Okay, so here's our two equations. So when we write our system, we're going to write X plus Y equals 38, and X plus 2 equals Y. Okay, here's our system. Now, remember in substitution, we are going to use one equation as our tool. So we're going to use this bottom guy as our tool, and we don't even have to rearrange anything here. Y is all by itself. So this one's our tool, and we're going to plug it into that top equation. So wherever I see a Y in the top equation, I'm going to replace it with X plus 2. So X plus Y equals 38. Right? All I did was replace this Y with what it's equal to. All right, and then I can solve for X. So X plus X is 2X. Subtract 2 from both sides. Divide by 2. And X equals 18. Okay, so X equals 18. And if I want to go back up here and plug it in to either equation, doesn't matter which one, because remember, we're looking for our one solution, and the one solution is what these two guys share, right? So I'm going to plug 18 in. Doesn't matter if it's this equation or this one. Either way, I should get the same Y. I'm going to use this bottom equation because Y is already by itself. Y equals X plus 2. Excuse me. And 18 plus 2, X is 18. 18 plus 2 is 20. Okay, so I got an 18 and a 20. So does that make sense that the AFC 118, the NFC 120, is this 2 more than this? Yep. When I add 18 and 20 together, do I get 38? Yep, so it makes sense. So my solution would be 18, 20. Yeah, these are a little strange to set up. Yes, it might take you a second to think it through, but there's always a way. So just go to that table. Okay, I'm thinking of 2 different things. Total number of games the teams each won. Or total number of liquid, total amount of liquid, and then percentage, right? Just try and break it down and make it easy on yourself. Let me know if you have questions.